All right, so we have a lot of times different problems that talk about calculating percentages. And we have seen in the Khan Academy how these were done using different strategies and tools and so on. But I wanted to share with you how to do these problems using the rule of three, okay? And this is one of the reasons why I always find the rule of three to be so useful, okay? So let's take a look at this and see how we can solve these problems using the rule of three. In here we have Elmer has a collection of 300 fossils. Of these, 21% are fossilized snail shells. And so the question is, how many fossilized snail shells does Elmer have? All right. So the idea is we have here that we have 300 fossils. So this represents 100%. So even if it doesn't say that, we are kind of surmised by the information that 300, okay, fossils is the 100%. Okay, so we have 100%, okay, of these 300 fossils. All right, and then we can calculate and say basically the question is, okay, 21%, how many fossils then do we have of this type? Okay, so that is our x. So here we have set up the problem using the rule of three. And it's always very important to set up the problem correctly, okay? And so that is where we go. And so of course then we do the cross product, okay, of this. And let's see, so we do the cross product. We have 300 times 21 divided 100, okay? So then we can see that x equals, okay, 300 times 21 divided 100, and that is what is going to give us the appropriate percentage using the rule of three. We could also use the spreadsheet that we have, okay? So if we have here our spreadsheet, we can actually change now and say, all right, let's say that here we have the fossils, okay, fossils. And then here we are going to put our percentages. So that is going to be percentages. So the whole spreadsheet changes that way. And we put basically the information that we have. All right. So we have 300 fossils is 100%. And we know that now we have 21% here. And so it actually calculates how many, fossils represent 21%. Okay. So that is a useful way of doing that. So let's take a look here. We have another problem. So it says, Luke and Matthew ran a lemonade stand on Saturdays. They agreed that Matthew would get 60% of the profits because the lemonade stand was his idea. And they made $25. Okay, so let's see if we are going to solve this problem. Okay, what do we get for setting up this using the rule of three? Again, we have that 25. Okay, so $25 is the 100%. Okay, so $25 is 100% here. And then we know that Matthew would get 60%. So we need to basically figure out what would be 60% here, and that would be our x. Okay, so then we can do again the cross product, 25 times 60 divided 100. All right, so that is basically the solution for that. Okay, so that is one type of these percentage problems. Let's take a look at a different type of problems, still dealing with percentages. So here we have, when a grizzly bear hibernates, its heart rate drops to 10 beats per minute, which is 20% of its normal value. Okay, so then the question is, what is the grizzly bear's normal heart rate when it's not hibernating? So the important thing here is to understand, and this the spreadsheet is not going to help you with this or anything like that. The spreadsheet may just help you with the problem that we have here before us. So we look at the information and we can see, okay, so the heart rate is 10 beats per minute, and that represents 20% of normal. So using the rule of 3, so we have that so 10 beats, okay, represents, okay, 20%. All right, so that is 20%. And then what is it asking? So it's asking what is the bear's normal heart rate. So we are basically trying to find how many beats per minute, okay, is going to be normally, and normally is basically our 100%, okay? So then we have the problem set up correctly. Can you see that now we start with what we know is a part of the percentage, all right, and we need to figure out the total. The cross product again works exactly the same. Now it's going to be 10 times 100 divided 20. Okay, so and the interesting thing is that this you don't even need to do a calculator or anything. You can just look at that. Okay, divided 20, so we can cancel the zeros. All right, and so we have. So that would be 100, so 10 times 10 is 100 divided 2. So of course that is going to be 50, okay? So 50 beats per minute is the normal heart rate of the bear, okay? All right, so let's take a look at another problem here. Anastasia is grocery shopping with her father and wonders how much shopping is left to do. We already have 60% of the items on our list, her father says. Anastasia sees 12 items in the cart. How many grocery items are on the list? So here we have, again, a similar case of what we had before. We are basically given what is a percentage, and we are trying to find out what is the total, all right? So we have, again, the same case here. So 12 items, okay, 12 items represents 60%, okay, oops, let me try that again. Okay, 12 items represents 60%. And so what we are trying to find out is the total number of items, okay, the total number of items that is going to be 100%, okay, 100% of that. So again, using the rule of 3, 12 times 100 divided 60. Okay, so that is how we calculate that. If we do the spreadsheet for these problems, okay, let's take a look at how the spreadsheet would work here in this case. In this case, we are going to actually have to switch a little bit things around, okay? So let's do the problem here of the items in the list. So we have that 12 items, okay, 12 items, okay, represent now 60%, okay? And what we are trying to find out is 100%. So 100% is going to be 20 items. So that is our answer there, okay? So there's another type of percentage problems here, okay? And let's read and try to do this one, okay? So let's see if we can do this one. We say, of the 50 US states, 4 have names that start with a W. And then it's asking, okay, what percentage of US states have names that starts with a W? So the 50, okay, so the 50 states, all right, so the 50 states, clearly that represents 100%, okay? And then it's basically saying, all right, so now we have 4 states, and what we are trying to find out is the percentage of this. So can you see that we are setting up, again, the rule of 3, really easy to solve. So it would be 4 times 100 divided 50, okay, divided 50. and that is going to give us the answer. But you notice that this is different than the first type of problems. In the first ones, we were given the percentages and we needed to find the fossils, okay, or the money in here. In this case, we are actually given the items, in this case the states, and we need to find the percentages. But things basically, work exactly the same either way. If we look at this other problem, we say, all right, there are 25 students in Mr. Nguyen's second grade class. In the class election, 4 students voted for Benjamin, 12 voted for Sahil, and 9 voted for Maria. What percentage of the class voted for Maria? So we are basically concentrated here on these 9 votes, all right? So we have, again, 25, okay, so 25 votes, okay, because everyone voted. That is going to represent 100%. Okay, so that represents 100%. And what we're trying to find out is the percentage of votes that 9 votes represent. Okay, so again, we do 9 times 100 divided 25. Okay, and if we bring our spreadsheet here, all right, here we are going to have votes. Okay, so votes, and the total is 25. In this case, we are going to find, okay, use this other part of the spreadsheet that is going to give us the percentage. Okay, so that is going to be the percentage. Oh, so here we need to, of course, put 100%. Okay, so 25 votes represent 100%. 9 votes is 36%. Okay, so I hope that this helps you see the different types of problems that you can have using percentages, and then the different setups that you can do. But you have to think how to set up the rule of 3 for each one. This one is the last case. Which one of these, okay, of these other previous cases is this last one? All right, so let's see which one it is. It says Challenger Elementary School has 800 students. Every Wednesday, 12% of the students stay after school for chess club. How many students attend chess club on Wednesday? So now the invitation here is set up the problem using the rule of 3, and which one of these other types of problems is this last one, okay?